Welcome to Homework Lib.
Hi, so over here we're going to have an object that is going to be launched upwards with an initial velocity of 6 meters per second from an elevator that is moving upwards with a different velocity of the elevator that is 2 meters per second. We know that the acceleration for the elevator is going to be equal to plus 1 meter per second squared, and on the other hand, the acceleration of the object is going to be equal to minus g, the value for gravity, right? So in this case, minus 9.81 meters per second squared. This situation is going to look like this. We're going to begin the object going upwards with a certain velocity, the elevator with a smaller velocity, and after a while, the object is going to stay up for a bit, and finally, the object is going to come back down to the floor of the elevator. So in order to find what is going to be this value, what we're going to use are the equations of motion for each of the objects. So on the first hand, for the elevator, we know that the position in the y-axis, let's label the y-axis as the vertical position as a function of time, is going to be equal to our initial position plus initial velocity for the elevator times t plus acceleration, in this case 1 meter per second squared, times t squared. In this case, the acceleration is 1. We can get rid of this meter per second. And we can write down as well the equations of motion for the object. In this case, I'm going to put up as a function of time. It's going to be equal to y0 plus initial velocity of the object as a function of time plus acceleration of the object. In this case, it's going to be minus g because it's going to be affected by gravity, minus g times t squared. The value for our initial position is going to be 0. This is going to be our point of reference for both of them. And now what we're going to use is at what time these two positions are going to be the same. So in order to do so, let's make the position of the elevator equal to the position of the object. This is going to lead us to the following equation. I'm going to replace first the values for the velocity of the object, the initial velocity of the elevator, that is 2 meters per second, and the initial velocity of the object, that is 6 meters per second. What we're going to get is that 2 meters per second squared times t plus t is going to be equal to 6 meters per second, so over here without the squared, times t minus 9.81 meters per second squared times t squared, and over here t squared as well. We can factorize on both of these equations at t, so this becomes 2 plus t is going to be equal to t times 6 minus 9.81 times t, t on the inside of the parentheses, 9.81 times t. T and t cancel out, these values for time, and we end up with a linear equation on time. Let's put all the times together on one side. We're going to end up with 10.81 times t is equal to 6 minus 2. Thus, the value for time will be 4 divided by 10.81, giving us 0.37 seconds. And this is going to be our final answer. As you can see, the other possible solution was time equals 0, because at time equals 0, the positions are going to be the same, equal to 0. And that would be all. Thank you very much, and have a good one.